Hello class, teachers and receiving students. Right, thank you. You may be seated. Now we look in our last lesson. We're still on forces. Thank you, Melissa, for the answer. All right, I brought with me two things that we can use to measure force. They actually measure weight, but weight is also the force. So we have one here which we looked at in our last lesson. Yes, Robert, spring balance. That can be used as a force meter, or it can be called a force meter when we are measuring force of an object. Here is also one, which is a Bartram scale. So you may find this mostly in clinics, but this is a digital Bartram scale which you can use to measure your weight. But you say, how can we measure the force of our weight? All right? Robert, I would like you to do something. You're going to measure yourself. So Robert, come to the front. Okay, face the class. Remove your slippers. All right, Robert is going to measure his weight. Michelle, can you read Robert's weight? Put your head up straight.
1 kg.
Thank you, Melissa and Robert. Okay, Robert's weight is 40.1 kg. So, but how is force involved? Okay, weight, as we know, is weight of an object, or for Robert's weight, with the weight of any object is the pull of gravity. Okay, pulling on the object downwards. So, when Robert's weight, when the force of gravity is pulling Robert down, that gives him his weight. So, when he's on the scale, his weight is 40.1 kg. So, we have to change that to force, which is about 40,100 grams. A lot of force. But anyway, we're going to look at today. So that is our lesson for today. And so our topic for today is change to force. So we'll be looking at topic number 1, change to force. So what do you remember about the unit of force when we are measuring force? Receiving student, what is the unit to measure force? Lorraine?
Newton.
Very good, thank you. The unit used to measure force is the Newton. And how much is 1 Newton? Anyone would like to give us a guess? How much grams is equals to 1 Newton? A 1,000? 1,000, any other answers? Okay, 1,000. Good. Our answer is 100 grams. Thank you for the answer. Good try. Is equals to 1 Newton. So, we are going to change grams, which is weight, to newtons. And 100 grams is equals to 1 Newton. All right? 100 grams is equals to 1 Newton. Here is your first 3 exercises. Change these 3 exercises that you will do to newtons. See how much force is released by each of this weight. How many newtons is this? So A, 300 grams equals how many newtons? I'll give you 3 minutes to do that. I wonder who will be the smartest person to show me the calculation of that. All right, your 3 minutes is up. But I'll give you 1 extra minute. Very good, continue. Someone has found a way to calculate, which is good, I will ask. Okay, how did you calculate it? Did you find a way? Your answer is correct, but how did you calculate it? Sorry. This is correct, this is correct, this one. If you calculate it, there's a way to calculate. All right. Good. I've seen so many people trying their best, receiving students. I think you have tried your best. All right. Let's see. To change grams to newtons, our first answer would be 300 grams equals how many newtons? 3 newtons. Very good. Receiving students, if you say 3 newtons, that answer is correct. 3 newtons. And our second answer is 750 grams is equals to how many newtons? Robert? Hands up, hands up. Let's see who will be the next one. Robert? Then we'll have
7.5 Newton.
7.5 newtons. Okay, Melisha?
75 Newton.
75 newtons. All right, I'll put these two answers here. We have B, our answer for B. B, we have 7.5 newtons and 75 newtons. C, what is our answer for C? Or 10 newtons. Any other answers? Okay. Okay, very good. Our answer is, all right, somebody's saying 100, so we'll just put 100. We have 10 newtons and 100 newtons. Two answers for B and A. Okay, let's have a look at how we're going to calculate that to get our answer. I found someone who calculated it, so we'll call that person to come up. Samuel will show us how he calculated to get the answers. Samuel, please show the class how you calculated it to get your answer. Remember that 100 newton is equal, 100 grams is equals to 1 newton. All right. This is how he got his answer. You want to explain? Okay, he divided, B is 750. Okay, 750. I wrote it backwards. 750 divided by 100 will give you 7.5 newtons. Let's see that. So let's do a long division and you find. So 100 divided by 750. So 100 into 750 is 7 times. So we have 700 minus 0 will give us 5 and 0. So 100. Can 100 go into 50? No, so we put a decimal point. And we add 0. So 100 into 500 will be possible. So how many times? 5. Oops. 5. So that will give us 500. Minus 0, 0, 0. So your answer would be 7.5 newtons. So that is how Samuel got his answer. And the same with 1,000 grams divided by 100 equals 10 newtons. All right, so our answer for B would be 7.5. And for C would be 10 newtons. Okay, good. Listening students, if you got those answers and you calculated it well, very good. So this is your rule to remember. When you change grams to newtons, we divide by 100 grams. All right, our next exercise. Is the opposite. What is the opposite? You have 3 minutes. Sorry? Mouseless. Okay. Not mouse. It's time wasting. Okay, good, good. Very good. Well done. Now, I think some of you have found the rule, so you're going to tell me the rule of changing newtons to grams. And I hope receiving students, you have found the rule already. Very good. Well done. Yes. All right. Good. I've seen many of you have done quite well for the second activity. So we shall begin with our first answer. Who should give us our first answer for the question, how many grams is this following newtons, do this following newtons have? A, we have 4 newtons. Who would give us that? Okay, Emmanuel. Emmanuel, first stand up. Second one, Moro. Ted. Wow. Pass the mic. Okay, Emmanuel.
400 grams.
Very good. All agree 400 grams, receiving students? I hope you have 400 grams. Thank you. Moro is our second person to give us the answer to B. 6.5 newtons is how many grams?
650 grams.
Do you agree with her? Yes. Okay, good. 650 grams. And the last one, C, 20 newtons. How many grams is that?
2,000 grams.
Very good, 2,000 grams. All right. So now you have those answers correct, receiving students. What do you think is the rule, class? What do you do when changing newton to grams? Anyone to give us the answer? Vanessa, good, thank you.
Multiply by 100.
Very good, thank you. We multiply by 100, and that is the next rule when you are dealing with forces. To change newtons to grams, you multiply by 100. Very good. I hope, receiving students, you found that rule yourself, and you should be proud. Thank you very much. All right. Teachers, you may give some exercises again on this exercise for this lesson in your own time. And down to our summary of today's lesson. We have only one summary point. Keyword for today is newtons. Our next lesson will be the second lesson of change to force. So teachers, your next lesson will be much more practical. So prepare some practical activities. You will also need some spring balance for the next lesson. And with that, thank you, class, and receiving students and teachers for your participation.